Today's lesson is on representing algorithm. Oh. Hi everybody, you're going to be your teacher here today, and I'm just going to take us through representing algorithm. This is going to be for year 10, but you don't have to be in year 10 to do this subject. I'm trying to get everybody through computer science within a space of 2 months, because 2 hours a day that's all you need to complete one GCSE, and that works out to be 120 hours, but that's just going to be, it's a little bit short, so maybe 2 months, 1 week, but we can do it. Okay, first I'm doing is I'm selecting the words that I'm going to be using. I'm going to bring it to full screen so you can see what's happening, and you're going to listen to what we're going to be doing for today. Let me bring it across my mouse, right click on these words, read aloud this section.
The main focus of this lesson is on developing flowcharts. This lesson assumes that learners have already covered the flowchart lesson in the KS4 Programming unit, but can also be used to introduce the symbols if required. A step-by-step worked example of a flowchart for a coin toss game is used to cover each of the flowchart symbols apart from subroutines, though you can ask learners to develop the dice roll simulation in the worksheet as a subroutine. Learners are also introduced to using structured English to specify the steps of an algorithm in detail, though this is referred to as written descriptions throughout the unit so as to not introduce more terminology than is necessary. Structured English is used to describe each of the searching and sorting algorithms later in the unit so that learners can focus on the logic of the algorithm, before later being shown programmed examples of all-bar merge sort. Learning objectives. Describe the difference between algorithms and computer programs. Identify algorithms that are defined as written descriptions, flowcharts, and code. Analyze and create flowcharts using the flowchart symbols.
Alright, so as you remember, I'm saying on the right hand side where we've got this download all files, this is where you just download all the files for today's lesson. Okay, nothing that us teachers are doing in computer science we've actually written ourselves. We may configure it in a way so that it's got our school logos on, but we haven't done that. You know, we haven't actually put this work together. Everything is the same. Yeah, everybody's learning the exact same thing. So whether you're on OCR or AQA, we are all learning the exact same thing. Okay, once you've downloaded these files, you will get these 4 files that will come up. It's going to be an A3 solution, then you got an A3 worksheet, you got a lesson plan, and you got an L2 slides, which is a PowerPoint slideshow. What I'm going to do is that I'm going to put this onto my site, and then in the description there will be a link for each one, just in case you have problems with downloading. Okay, now the first thing I would say is to click on the lesson plan and see how you would structure your lesson. So right here we have ask the learners to read the Lego instructions and consider how well these could be followed by different people. Okay, so how well they can be followed. I just made it bigger because I know that some people may have difficulties with their site. So the aim is for the learner to realize that very clear. So the aim is for the learner to realize that very clear, decomposed solutions to problems mean that it is much more likely that they can be followed and the outcome repeated no matter who uses them. Lego instructions are also a visual language, making them more universal than the written language. Okay, this is supposed to take 5 minutes. Right, this is on the second slide. So remember I said to you there's going to be 4 files. Now if you choose the PowerPoint, you can see the PowerPoint logo on here. It's the red one, and then you double click on that or right click open. I've got one open already. So lesson 2, representing algorithm. I'm just going to show you something here. At the top it says slideshow. I select slideshow and I click from the beginning, but I'm leaving it to hover just for a second so you can see what it's saying. On the top it says if you press F5. Okay, so this is a shortcut key. This is what you cross. It's a shortcut key. Pressing F5, press F5, and here you go. The slideshow begins. Building Lego. Imagine giving these Lego instructions to 5 different people. Question. This is not me having to say question, but it's a question to you. Do you think that everyone's finished product will look the same? Okay, so imagine giving these Lego instructions to 5. So you're going to give the Lego instructions to 5 different people. Now, will those 5 people come out with the same solution? Will they have the same execution? And why would you think this? Okay, so you think about it, you write it, you pair it, you share it. Now, if you've got a group of people and you're just working in the library together, you know, lockdown is here, you may be at each other's houses or in the park just sitting down with your laptop. You know, you might have Lego, you may not have Lego. It doesn't matter. Just think, if you was given these instructions and you gave it to 5 different people, would it be the same outcome? Okay, next. All right, representing algorithm. In this lesson, you will describe the difference between algorithm and computer program, identify algorithm that are defined as written description, how flowcharts and code, analyze and create flowcharts using flowchart symbols. Algorithms. An algorithm is a set of precise instruction expressed in some sort of language. It can be textual, like text, so you might be writing out your information of instructions, or it could be visual, as in pictures, as we just saw. Understanding the language is necessary in order to execute their instructions. That's why you usually find in some instructions that's given to you, like if you went to, I was going to say IKEA, but IKEA's got the worst set of instructions. Now, if you was putting together a Hoover, you'd have written instructions, and they'll probably give you a diagram of each part of that Hoover and how you would piece it together. So that means if you cannot understand it textually, because English may not be your language, you would understand it visually, and that's what they're hoping for. Executing these instructions is meant to solve a problem. Correct. Right, so like as you can see, there's a picture here on the right hand side, top, and the top has to go over the person to wear. And this is what they're hoping that the person is going to put on the top correctly. Algorithm and computer programs. The terms algorithm and computer programs can often overlap but are distinct from one another. What do you think the difference between algorithm and computer program is? Okay, so what do you think that the difference between an algorithm and computer program? If you want to press pause, you can go onto Google, you can type it out. You can go onto Bing, do the same thing, type it out. You could actually just go onto YouTube and have a look at the difference between an algorithm, you know, watch a couple of programs if you want to extend that time, or, you know, look at computer programs to find out the difference if you want to, or we just move to the next slide. Algorithm and computer programs. An algorithm describes the logic of a solution. A computer program is the implementation of a solution, of this solution, written in a programming language. Programming within a programming language are precise enough for a machine to translate and then execute. Representing algorithm. In computer science, algorithm can be represented in a number of ways. Not only in a programming language. For instance, you can use flowcharts, and you can use written descriptions to help you to focus on the logic of a solution without worrying about the syntax errors. This can massively speed up the development time of a program. Flowcharts. A flowchart can be used visually to represent an algorithm or a program. Okay? Arrows are used to signify the flow of the program. So the arrows are showing the directions of which way this program is going. Sometimes you may have a loop, sometimes it's just going to be one way. So you have start, you go down, input your year that you're born. Okay, so you could put 1972. Then it says input your current year. So this year, 2021. Result equals current year minus year born. And then it's going to output the result. What would that be? 31 years, for 40 years, what's it going to be? And then it will end the program. So you're always going to start the program and you're always going to end the program. Look at the box that they're giving you, the type of shape that's given. It will look at the type for input. You know, you have the same type, and the output and the input, they actually use the same shape. Results equals current year, born. That's a different type of box. Okay, we got to remember the shapes of these boxes as well when you're doing your flowcharts. What does this algorithm do? And we kind of like know that. Okay, next. Written description. A written description can also be used to specify the steps of the algorithm. Okay, so let's bring it down into how it goes. We're not going to say, oh, start. Okay, we're going to use ask the user for the year they were born. Okay, that's the first that's that first box. Ask the user for the year it currently is. Next box. Subtract the year born from the current year. Step 3. That was the next box. And then tell the user how old they will be this year. Okay. Output result. Okay, end. Next. Computer program. Once the logic of an algorithm is planned out, you can use it to help with the written code in a programming language such as Python. Year underscore born equals int. And then in brackets is your input. You've got a set of brackets inside, and that's for you to enter your data, and then you close the brackets. Current underscore year. If we look at the right hand side and look at the left hand side, if the right hand side says year underscore born, in this you put they've put year underscore born. They said current user underscore year, and then here on the right it says current underscore year. Result equals current underscore year. Then you have on the right hand side current underscore year minus year underscore born, and the same on the right. Print. So output is print, and you're printing the result. Okay, and you've actually defined the result above, the one line above. Result equals current year, current underscore year hyphen year, and then you're saying print the result. Okay, so that's what you're doing here. All right, let's go to the next. Creating flowcharts. In the next activity, you are going to develop a flowchart. First, though, you need to know what the different flowchart symbols are and what they represent. Okay, so you're going to create a flowchart, and remember what I was telling you about knowing what they are. What I'd like you to do, if you can, got the time for it, is just go onto Google, have a look at flowchart symbols, have a look and see which ones is which. Try and familiar yourself with these different symbols. Go onto a YouTube video, watch that. But these answers are going to be here anyway. Alright, so flowchart symbols. Start. Terminators are used for the start and end of subroutines or programs. Okay, arrows are used to show the direction and the flow of the program. Welcome. Okay, so that information that says welcome. Subroutines are represented by a rectangle which with 2 lines on either sides. Okay, then you have flowchart symbols. Output, hello world. Input, name. Okay, when I mentioned that to you before. And an input or an output is represented by a parallelogram. And then, not a square, a parallelogram. Okay, squared equals number 1 times number 2. Process. This is represented by a rectangle. It is used for an instruction or a command. And then you've got age 16 is a decision. Okay, so age less than 16. So the less than sign has been put in there. You have true or false. It's a decision. Are you going to go true, or you're going to be false? A decision has two branches, true and false. Okay, so that's a decision. That's that symbol here. Now let's go back. There's no decisions in here, so there was no decisions that were used. But there's a subroutine. There's a decision. There's more decisions, and then there's a execution. There was a, as they put it, a process. So have a look again, and there's your processes. There are 1, 2, 3. There's 3 processes in here. Right. If you want to, you can actually go back to the videos. You can actually press pause. You can write it out on a piece of paper. That may help you at the same time to get that correct, to get that information in. All right, now let's just bring it to the full screen. Written description for coin toss. The following slides go over step-by-step breakdown of a flowchart for a coin toss game. Okay. This is activity 3. The instructions for the game can be written as ask the user to guess heads or tails. Simulate a coin flip by randomly generating either heads or tails. Compare the coin flip with the user's choice. If the coin flip is the same as the user's choice, tell the user they won. Then you'd end it. Otherwise, tell the user they lost. Okay, sweet. I'm just going to go back a bit. I just want to see what's available here. All right, let's have a look. Nice. All right, so that was your activity 2. And this was your activity 1. Okay. Now, I just want to go into okay, I'd like you to press pause, and then I would like you to try this out yourself. Try it out yourself before we move any further. I'm going to bring it to this screen, which shows me the activities. Now, we've gone through this so quickly. See, as you notice that in a class environment, this would take much longer. When you're doing it by yourself, we can just flow through this. So creating a flow chart. So you're going to tell your learners, this is the section where you are right now. Okay, so you should be pressing pause right now and then trying to work it out. And there's going to be some sheets. Remember I said I'm going to put some links below where you can use the worksheets, or you can have a piece of paper of your own to go through it. All right, now. Okay. Ask the user to guess heads or tails. Store the response in this called choice. Flip equals random pick heads or tails. And that gives you a choice. Compare the coin flip with the choice. So choice is equal to flip, true, false. Then you have your output you won, then you have your output you lost, and then you have the end. Okay, I'm not trying to stay on that because I would hope that you would have tried that, and also you could press pause at the same time. Dice roll. Now it's your turn to create a flowchart for a dice roll simulation. Use the written description included in the Activity 3 dice roll worksheet, which is below, or you can take it from the side to develop your flowchart. This is something that you should practice. You should actually practice doing these flowcharts. Once you practice doing these flowcharts, it will be so much easier for you, especially when it comes to an exam time, to work out the difference between certain things. It's not about cheating now and saying, oh, well, I don't have the time, I'm just going to copy what you've just written, sir. I don't do that, because yes, you can get it wrong, not a problem, but you tried. Get it wrong, see what you did wrong, and then you can try it again. at a later time. Then the more you get used to doing it, when your exam comes and there's an exam paper and talks about what these symbols are and what they do, you will know them. Yeah, so don't just try and just get it for this moment. Let me just move on to the next video. Let me try and work it out. You need to try and work it out for yourself. All right, peer review your flowchart. All right, sit down with a partner and peer review your flowchart. Check the logic of the flowchart will result in the intended outcome. Use the worksheet solution to help you with this. Okay, so you can do that. And then there's a homework. Right, this is due in the next lesson. Oh, my next lesson? You don't need to send this to me. You just need to try it. So read it, pause the screen, and then try it. Okay? Well, next lesson. In this, you describe the difference between algorithm and computer programs. Right? So this is, in this lesson, this is what you did. Describe the difference between algorithm and computer programs. Identify algorithms that are defined as written description, flowcharts, and code. Analyze and create flowcharts using flowchart symbols. In the next lesson, you will use trace tables to walk through algorithm in code. Okay, so in the next lesson, we're going to go through the trace tables. Well, thank you for staying with me on this one, and until the next time, I will see you soon. Peace.